All right, good. I wanted to make sure they actually showed up. Cool. My name's Ryan. I am the creator of Solid.js, as already mentioned. Solid.js, in many ways, is like pretty much every other JavaScript framework. It manages states, renders UI on the browser and in the server. It does have a reputation for performance, but it's probably most known these days for popularizing the term signal. And we're going to talk a bit about that today. Like, what's going on here? If you were to believe what you read on Twitter, you might be picturing something like this. I've seen more memes than you can count at this point. You've probably seen more memes than you can count at this point. But yeah, it really does leave the kind of question, like, what's going on here? So we got to go back in time for this a bit. If you went back about 3 years ago, you probably would have not heard anyone talking about signals. There were a few libraries that used something very similar, but they hid them behind kind of configuration objects or class decorators. So yeah, I'm not talking about Solid.js. Even though I had open sourced it back in 2018, I think we had about 800 downloads a week 3 years ago, even. So no, I'm talking about stuff like Vue and its options API. I'm talking about Ember and its auto-tracking computed properties, and things like MobX. So like, signals have been with us kind of all along, even if you go further back to like 2010 and Knockout.js. But fast forward 3 years, and like, you wouldn't believe it, right? You'll find signals in the core of like JavaScript frameworks everywhere. I've got Solid, Vue, Preact, Quick, Angular. Honestly, like, how in less than 3 years, honestly, mostly in the last like year, maybe 6 months, have we seen such a wide ecosystem change? We honestly haven't seen this amount of alignment in frameworks since the rise of the virtual DOM. So that's what we're going to be talking about today. But we should really, as I said, start at the beginning. What are signals? Yeah, I already kind of established this. I clearly did not invent signals, and I apologize a bit for the name. It isn't really the clearest, but again, I also didn't come up with the name. The thing is, these primitives have gone by different names over the years. You might have heard terms like observables, not to be confused with observables in RxJX, completely different thing. So yeah, I mean, this is why we kind of got here. Signals get their name actually from digital circuit modeling. There's a bunch of research in the 1970s looking at it, academic papers, and it's, as I said, the name itself I got from a library called SJS, which was based heavily on that research. Elm used to have a reactive system that used the term signal as well, so I just adopted it because I just wanted it to be called anything but observable. So that's how we ended up with the term now. But again, what are signals? The easiest way for me to explain it is you can view them kind of like a spreadsheet. In a normal assignment, represents like this moment in time, right? You have A, and after this line executes, you basically get a sum of B and C. But at some point in the future, let's say you change the value of B, you need to do the sum again if you want to get A. And I say this relationship does not hold through time, where with reactivity, it does. A will always reflect the sum of B and C, even as B and C change. So signals are really just a set of primitives to do the synchronization. And really, there's really only 3 parts, which makes this a little bit simpler. There's not like 50 operators or anything. It's just, there's 3 things you got to learn here. There's the reactive state, which is our namesake, the signals, which it's an atomic value that gets tracked. If that doesn't make sense to you, I hope it will in a minute. Then we have derived state. In Solid, we call these memos, and other libraries, they call them computeds. And this is basically any value that's kind of derived from other values. And finally, we have our side effects, which is where we get a chance to affect the world outside of our reactive system. That's what signals are, these 3 pieces. So I'm going to give a little example here, right? Because the first thing we really need is a new primitive, right? So I've introduced this syntax, and the way I've put this example is a little actually awkward now. I realize like it's almost upside down for most people, but if you get started in the middle here, you'll see that we have this create signal. And you can think of signal, when I say primitive, I mean kind of like you have a promise in JavaScript. It's just like simple container that lets you represent some kind of data relationship. So in our example here, we have a signal with John, and what I'm doing here is I have a greeting function where we pass the signal, and what the signal has is it has two values. I'm using a tuple here, but essentially it returns a getter function and a setter function. That's the key to this. So we can basically, in this case, we're greeting our friend here, so we say hello, and we call name as a function to get the latest value, and then it'll console log say hello John, which is the initial value. Then we set a new value, Mary, and greet them again, and now it has the latest value. This itself isn't much different than a normal variable. But where this gets kind of really powerful is when we introduce our second primitive, which is our effect. And the key to our effect is it lets us condense our code significantly. When we have effects now, we can kind of set that rule. It's like that A equals B plus C. So now we're saying we have this effect that we're going to console log whenever this friend value changes, right? So we have our getter function and our setter function. The effect runs once, and it displays hello John, because we're console logging it. And then later, when we set Mary, we don't have to do anything else. It just immediately runs the effect again, and now it console logs hello Mary. So this is our spreadsheet. What's interesting, though, is that this has the ability, I call it to be transitive, but the idea is if we want to manipulate that value, perhaps make our friend's name uppercase for some reason. I don't know why we want to make it uppercase, but we decided to make it uppercase here. We can still access in our effect that uppercase value and have the same thing happen. Run it once, hello John, uppercase this time, and then set friend to Mary and say hello Mary. And you might be kind of wondering how this works, right? Maybe this is a compiler, but the answer is actually a lot simpler. This is actually completely runtime using JavaScript stack. There's no compiler here. And I'm going to quickly explain how this works. You can kind of picture signals, really, to begin with, as just a simple wrapper over a get function and a set function. As I said, trust me, this will be less than 50 lines of code. It'll be easier than when you're on that last interview and they're like, implement a promise. This is much simpler. So what we need first, besides just getting our initial value and reading it and writing the next value, is we're going to need a subscriptions list. And this is how we keep track of these changes. And we use this, which I'll show in a moment here, is we have this global stack. So it's outside of everything. And I'm calling it context. And we need a way to get what's on the top of the stack. So you can see here we're just getting the last element. And then we have our effect, which is the other side. And our effect, as I mentioned, it just executes once immediately. But the whole trick here to how this works is in this execute function. Because when we get to our execute function, it pushes itself onto the stack. So it's in that global place. That way, when you run that function, which if in our example a moment ago, we were console logging through that uppercase name, it will call that function. So now you're running it, and it's going console log, and it gets to the name, or uppercase. It calls that function, which then eventually calls our signal, which then calls our read function. Right now, it's just returning a value, but we can do a little bit more here. What we can do is, when we read it, we go, hey, is there anyone in the stack? If it is, add the current listener to our subscriber list, and then return our value. So in this case, it will see that it's running in that effect, it will console log the name, and then it'll pop itself off the stack, cleaning up after itself. At some point later, what we're going to do is we're going to write our new value, set the name to Mary. And at that point, we just set the new value, and then we go through our list of subscribers and recall our execute function. And what this does is we just start all over again, because now that it's recalling the execute function, pushes itself back on the stack, runs it, and tracks everything all over again. So, as I said, no compiler, just a matter of manipulating a global stack. Powell from the Angular team, who recently implemented signals there, touches a bit on why signals are so exciting. And we like them as framework authors because synchronization is the heart of what we do, right? If you interact with the UI, you want it to be in sync. right? You want to make sure that like what the user sees is what they get. Without that kind of guarantee, you might have users thinking they're performing one action and because they're seeing something, but in reality, something different happens. And that could cause detrimental effects even when you're not in, say, finance. But also, there's some really nice properties here about using this kind of declarative code like we talked about, right? These relationships are set once and then executed. You describe behavior rather than implementation. And they're composable. It's easy to wrap them like we saw with the uppercase. It's easy to modularize them, pull them out. But really, it's more than just a win, on developer experience, right? Now, the virtual DOM is not a bad thing per se. But reactivity removes its reason for existing largely. I'm going to show you what I mean. So we're gonna take, sorry, oh, crazy. Okay, sorry, 1 second. Apparently if I hold shift, which is not control, it goes to the end of the slides rather than swiping on my machine. So let's get back to where we were. All right. All right. Is this where we were? All right. All right, cool. Can everyone see the code? Is this big enough? Maybe I can boost it one more. What are we at? 150? Let's do 160, okay. So it's funny, when people look at reactivity, it always starts with this like, hello world, hello name thing like we just did, where we have an effect. And let's see if I can actually blow up the console down here too. That one doesn't blow up. So hopefully, yeah, I guess you guys can't really see it very well. It says the count is 0 and the count is 1 as I start our signal at 0 and then set it to 1. So let's move away from this really quickly so we can see it. So what I'm going to do is instead of just doing a hello world kind of thing in the console, why don't we actually do something a little bit more substantial here and create like a real DOM element. And if we do that, we can go like what, document. I'm just using some DOM APIs. So get element by ID for our app, and let's append our H1 element. So if I do this, and now I'm going to, instead of console logging, what if I just said H1 text content equals this? So we're just going to do that. And if I did all my work right, we should be able to see something right now. Oh, extra period there. There we go. The count is 1, okay? So now I have an H1 which has an effect that updates the text content whenever we set our signal. Of course, we did it so fast that we're not even seeing it. We're just seeing 1 here. So that's not really useful. What I'm going to do, actually skip ahead here to save time, and show it again, but this time I've implemented a button. Again, just DOM APIs. Create a button, set its text content, and then on click, we set the count to count plus 1. And again, we just append our H1 and our button to the DOM, and if I click on this, we have a working counter. And all we're doing here is this one effect that I wrote a moment ago. Whenever the count changes, it just updates the text of this one H1 element. Now, great, but I mean, no one's going to write their applications like this. It's really, really, clunky. So, wouldn't it be cool if we could maybe find some shorthands? I think maybe use something like JSX. What if we could, instead of writing all this stuff, just essentially kind of shorthand it here. So what do we got? On click, and then do this, and hopefully our button still works. Okay, it does. And similarly, for our H1, we could be like, let's make it an element. And you can get a picture. All you need to do is have your JSX basically compile into these create element calls like we were talking about before. This one's a little interesting because we're like, okay, how do we know to track the signals? So what we actually do in Solid is we look to see if you call a function into JSX, and then we're like, okay, if you call a function, we should wrap it in a create effect. So you can just see that it basically compiles to that. And if this all, again, works, we still have a working counter. But again, this is still a lot. So maybe when we're building an app, we might kind of pull it out into something like this with counter, and then we're like, okay, let's get rid of all this extra stuff we don't need. And let's grab that, put it inside here, and then maybe we will return an array, which is h1 and a button, and then we will call our counter function. I'm just going to call it a function right now, and it's showing me a bunch of stuff, so we actually have to spread it in, and if we have prettier in here to make it a little nicer, okay, we're doing okay, it's still doing it, but again, like, this is a little bit verbose. Let's move this into here, move our button into here, and now we don't need all these extra declarations. Honestly, an array is kind of clunky. We probably just want to use like something like a JSX fragment. And if I format this again with prettier, and this is a lot, like just calling our function and doing all this. It'd be convenient if a library could just give us the ability to just like make a simple function call to do all this mounting for us. So I'm just going to do this, and then do this, and then what do we call it? Counter, and we get it from app. And if all works well, I think I can click this and it still works, and this might look like some code you might have seen before somewhere else. Kind of funny how it works. But I want to point out that something very different here, because if we console.log, count here, we're just like, hey, you're going to see this small little count thing here, which is really small, unfortunately, on the screen, and I can't seem to blow it up. But if I click this like n number of times, it only logged once, and it makes sense because we only called that function once. You saw me. We just called our counter once, and the only thing that's changing is this effect that's in this one kind of text node. So it doesn't really matter, how much we add here. We only need one effect to update the one text node. Okay, so this is a little different, right? This is an example of how you can use reactivity and no virtual DOM. Okay, so let's move on from that point here. Sorry, getting my mouse back. There it is. All right. The thing is, pretty much all signal libraries actually use a virtual DOM today. So this is kind of a place where, say, Solid's approach is a bit unique. But even so, a lot of these libraries can still use signals as a way to reduce the amount of component re-renders. Signals decouple updates from the hierarchy, and you don't really actually need a fancy compiler to do it. It really doesn't matter how many components you have, because the updates are independent of components. It's just like this effect that runs. Okay, so they also kind of universalize how we look at state. Because it's not that, it's not the components that drive change, it's these signals, right? Like in this really simple example here, you could just basically move the signal out of the component or our function that runs once, and it still works because it has nothing to do with components. As you saw, we were just typing it directly in the console there. Honestly, I wouldn't recommend you to do all your global state like this because you're going to be passing stuff through your tree. You want ownership. You got to actually manage it. But again, I really want to emphasize component boundaries are for your sake, not because of any mechanical or performance consideration. So in the case of something like Solid, obviously components just don't re-render, and all update life cycles are independent of component boundaries. So you can nest a signal inside a for loop and be fine with it, and each iteration can own its own for loop. You don't need a separate component for that. Kind of continue this discussion on why this is powerful is because reactivity naturally separates static from dynamic, which leaves us open to make optimizations for each. Reactivity already is amazing for updates because, as you saw, you just update a single text node. But since it doesn't need to re-render things, we can optimize for creation too. In Solid, we actually clone full DOM templates because we separate what runs. This is actually lower in memory and it's more performant. And it also has this
nice side effect that when you do server-side rendering and have to hydrate, hydration and server-side rendering, hydration and rendering are basically the same thing. You just skip creating the static parts. essentially, when you create a new component or render a new part of the page in something like Solid, you clone a bunch of DOM nodes, and then you attach all those effects. When you hydrate, those DOM nodes exist. You just attach all those effects. And the cool part about this is you can exploit this even further because you don't necessarily need to always send all those static parts to the browser if you're server rendering, right? So remember, with a reactive render, something based on signals, it scales on interactivity, not on view size. It's not about like how much markup you have, because you're not making elements for all of it. It actually scales on how many interactive points. If you have a bunch of your page that like literally does nothing, you don't interact with it, like there's no extra dynamic code there. So I actually have another example for that one here, just to kind of show you. Like, this is a simple movies app, Taste Movies app. A bunch of frameworks have been implemented. The Chrome team at Google was encouraging us all to make demos for it. I just want to show the experience of this one because we made it. The actually community made this site. I didn't actually make this site, but it's like a very simple thing site. It's funny. I'm using like something that looks almost like the browser bar, but if you see this thing doesn't actually spin, this is actually just a client-side application, and I'm relying on the conference network to be reasonably good to show what I'm talking about. So we've been, apparently that one doesn't have a good image. Did I just lose the internet? No, we're fine. But this is a fully interactive, not terribly interactive, but like you have a navigation experience. There's a search here. I'm going to put drag in or something, and we can see that the application works and it's interactive. And what's cool about this separation of static and dynamic is you might be asking yourself, like, I mean, I'm going to propose a question, like, how much JavaScript do you need to run an app like this, do you think? Right? And the funny thing is actually not that much. This is an experimental demo from Solid Start, but this search page here, we're looking at 14 kilobytes, but actually let's start on the home page for a second. I'm going to refresh the page here. Okay. So yeah, 13.2 kilobytes. And as I navigate around here, what you're going to see actually, funny enough, is because it's just to load some anchors and stuff, is our page, like we've gone to a couple different pages here, and we're still at 13 kilobytes. And the search, when I get to that, well, okay, we need a little bit more code, and now we're at 14 kilobytes, so we can do the search. My point is, this is an example here where we're doing client-side routing and using a new hybrid routing technique that I'm not going to get into too much today, where we actually send HTML over the wire and only send the small bits of interactivity we need in JavaScript. But this is all possible because of the power of signals and separating the dynamic from the static. So trust me when I say it, but you can check it yourself. Go in the Taste Movies app and navigate around a few pages and see how large that is in other approaches. Just putting it out there. But speaking of hydration, why do it at all? My previous example showed how you can eliminate, like, say, 85% of hydration and preserve client-side routing. But what if you want to eliminate that last 15%? I actually have a little experience there. My previous job at eBay was building their next-generation open-source framework, Marco. And they found me in 2019 because of my writing about Solid and removing that need for components. They realized signals could be key to removing initial hydration from the browser, since if we know what updates, we can carefully serialize that state on the server when it runs, and then not have to rerun it in the client. And I think you've already heard this concept earlier in this conference today. This term's been called resumability, popularized by Quick and Misko Hevery. And this is yet another application that's very tied to the use of signals, because only through the separation, through reactivity, can we get that granular ability to basically wake up our apps without even hydrating. Okay, I got another one. This one's fun. What if you not only visualize your component tree, but you had dev tools that actually could trace how your data flows through your app? Like when you update one value of state, you can actually look down and see exactly what changes somewhere else. This little snippet was a video made from Damien, who works on our dev tools. And it's really quite cool, because I'll play the video one more time. Hopefully, no, okay, let's go here. You can kind of see he actually sees both he goes too fast, but he's got the layer of components on the tree, and he has all the state changes as they pass through the app, and he changes one little thing, and he can go, oh, it updates this one thing down here. This ability to have this traceability and understanding of what updates in your app when is an incredibly powerful thing that you can do with signals, because we know all the dependencies of how things work in your app, simply from the way you wrote it. But there might be some people who've been around a long time, like myself, and this probably sounds a lot like those JavaScript frameworks that came before React, things like Knockout. And I love Knockout, but I also love React. And signals don't preclude you from really cool things like unidirectional flow, strong interfaces, and explicit setters. And I want to assure you that this time it is different. And the best part is you actually don't have to trust me. I didn't even invent any of the things I'm going to talk about here in a second. First of all, predictable synchronous execution. MobX has shown that with guarantees we need, with the guarantees we have in our reactive system, we can ensure that it stays glitch-free, to ensure that updates propagate in an effective and predictable manner. That is, on any set of changes, it actually only will hit one node once. There's no cycles. It essentially will ensure that everything runs in order and once. Another one is a little less known, but there's a library called SJS that showed us by registering our effects within our parent effects, basically making a tree of hierarchy using our reactive system to actually do our garbage collection as well. We can have reactive systems clean up after themselves. This is significant as it solves the classic problem of stale observers and the leaky observer pattern. And finally, there's nothing to say that you can't schedule updates. Modern reactive frameworks are actually what we call push-pull. They don't just notify, they actually schedule the work in the future and then pull the values out, which is cool because they know exactly what changes, and then you get the schedule when the work happens, effectively basically writing them to a queue. And this is really powerful because this ability to use push and pull makes it possible to perform really complicated orchestration, things like suspense and transitions and concurrent rendering, all possible with signals without a virtual DOM. So I'm going to finish with a couple takeaways. Modern front-end development for years has been about components, class components, function components, option components, web components, and for good reason. Components are these essential building blocks that allow our program to be modular and composable. But however, in almost every JavaScript framework, they rely on components they have runtime implications. The update model and life cycles are tied to them, and this has a profound impact on how we build UIs. And this isn't really necessarily a desired quality. I love this quote on the slide. This is from Werner Vogels from Amazon. And I know he's talking about the cloud platform or whatever, but seriously, I put this in every talk just in case. Signals empower us because they are powerful composable primitives. They are trackable, analyzable, dependable, and performant. They are the building blocks of our application, and in Solid's case, actually like the whole thing. They provide a language of change unto themselves. The focus on primitives is increasingly important as we enter a world of compilation and artificial intelligence, where clear intent of code is as important as its implementation. Where memoization gets supplanted by reactivity, chances are you'll be using signals in some form either behind the scenes or directly in your web UIs for years to come. If you like what you heard today, you find all the resources you need off solidjs.com. You can also find me on Twitter at Ryan Carniato, and if you really like nerding out on JavaScript framework stuff, I stream weekly on YouTube and Twitch. Thank you.